Hello, everybody. My name is Josh Campson. I'm a Georgia expat. I'm now living in Texas after a tour in the military, finishing my degree at Kennesaw State. I'm going to be talking about logistical improvements in naval shipbuilding. All right, as I mentioned in the intro, I'm talking about improvements to naval shipbuilding. I'm going to really try to fly through this because there's a lot of material to cover in 10 minutes. So, what you see right there is a map of global shipping lanes. Global shipping, obviously, extremely important to the world economy. Not much more efficient way to move goods than on a ship. You got buoyancy helping you out. Now, shipbuilding itself is one of the more inefficient construction projects you can undertake. It's more like building a building than a vehicle because it kind of has to stay in one place. Doesn't move much. Hard to use the assembly line method. We'll talk a little bit about that later. Now, the U.S., as you saw on the previous map, really needs maritime trade to interface with the rest of the world. And so at the center of our economic and foreign policy is our gigantic Navy. And this Navy, unfortunately, is aging somewhat. It was initially built with the Cold War in mind, where you had Russian ships. Basically, the big threat that they offered was these large missile attacks from their ships and their planes, trying to take out one of our carriers. And so you have a carrier protected by a bunch of smaller ships, Aegis ships, which are designed to shoot down a large barrage of incoming missiles. But what you're seeing these days, now that the Cold War is over, is there's still the need to protect those carriers. They're a golden target for many regimes, but you also have all these hot spots popping up, smaller scale conflicts, piracy, threats to international freedom of seas, and ballistic missile threats. And to handle all these missions, basically we're having to peel off these small ships like destroyers and cruisers from carrier protection and have them go into all these different parts of the world to conduct their missions. Humanitarian, that's another big one. And what we're quickly realizing is that we don't have enough ships to meet all the needs that we want for the Navy to meet. One of the big reasons for this is we retired the Perry-class frigates, part of the Cold War, but now they're obsolete. All of those were retired, the last of them in 2015. We also, one of the big roles now is Aegis ballistic missile defense. So basically you'll have a ship sitting off North Korea in the Black Sea or near the Strait of Hormuz facing Iran, places where we think that people are likely to launch ballistic missiles with chemical or nuclear weapons. These ships can basically engage these missiles when they're being launched or when they're falling out of space. And so we have them protecting Japan, protecting Saudi Arabia and Europe. And that means that they really can't move. They have to stay there, and they have to have a couple wingmen. So that's a further drain on the amount of ships that we can peel off for patrol duties. What you see right here is the estimate for the fiscal year 2015 of our ship requirement, which was 308 total. And as you can see, we came in way short at 271. That's almost 40 ships under what we think we need to influence the world in the way that we want to. Added to that is President Trump's commitment to build up the military. He wants 350 ships. And so the Navy's planning for 355 ships. You look here, you see the large surface combatants, small surface combatants. Those are the ones that are going to be filling this kind of more versatile role of patrol. Now, the ships that we kind of had coming up to replace our current small ships are the DDG-1000. This thing really amazing in concept, but turned out to be a giant lemon. Over budget, tried to put way too much technology on it, and very difficult to manufacture, so they're only going to make 3. That's not going to help with the 40 plus that we need. They were hoping that the littoral combat ships would fill that role, but they also are over budget, over complicated, and the other thing is they are designed to run on a skeleton crew. The problem with that is you kind of need a minimum amount of sailors to keep a ship functioning if that ship stays at sea for like 6 months at a time. They got to maintain the ship, chip off rust, repaint it, maintain the engines, all that good stuff, and you really can't do that with the numbers that they designed the ship for. So what they're doing instead is they're trying to build more of our Arleigh Burke class destroyers. You know, we've already kind of got a production line for that. And then, of course, we'll always be building more of our aircraft carriers. There's the Ford undergoing sea trials. All this translates to a huge need to put out ships more efficiently, you know, to replenish the fleet. So what are some things that make this industry so inefficient? One of them is, as you see here, the keel is laid and the project basically becomes stationary. You have to have an army of workers crawl on it, inside it. This far cry from the more efficient assembly line method that the automotive industry uses, where you have the goods basically going down a track, passing stations where the stations, whether they're robotic or human, conduct repetitive tasks. Instead, you have really highly skilled workers having to jam themselves in all kinds of positions, get in harnesses and go down the side or down the middle even, or crawl into tight spaces, lower their gear into tight spaces. Very, very labor intensive, this effort to build a ship. And on top of that, you really have to have skilled personnel. They have to basically be master, or, you know, a lot of them have to be masters of their trade. And this means that they're expensive and they're very hard to train. And so another difficulty is that at the shipyard, you have parts being ordered from all over the country, kind of in a haphazard manner, all kinds of different companies and delivery services. So the parts, any number of them can have defects or be late. And if it's a critical part, that's going to down your whole project and set it behind while you order another one or a replacement. And it's very, very easy for problems to arise this way. Another problem is just kind of the way our government handles shipbuilding. They, you know, they don't really run it like a business. The biggest example that comes to mind is they require a 30-year plan to be put out for all naval shipbuilding needs in the next 30 years, but then they basically change that every year. So you have this huge overhead cost of coming up with this huge plan, and it changes every year. And it also, not only does it just waste money for making the plan, but, you know, when people try to follow the plan, there's all kinds of confusion and inefficiency that follows. Just adds to the problem. So what are some solutions that can help our naval shipbuilding industry? Well, the first thing we can do is we can learn from commercial shipbuilders. And the commercial shipbuilding industry is dominated by Asian shipbuilders. China, South Korea, Japan, they pretty much own the market. Nobody else even comes close, including the U.S. They, for a very long time, have used computer-aided design to plan out their ships. And this kind of seems almost second nature now, but the fact is that this is something that is only just now catching on, just recently catching on in naval shipbuilding.
The predecessor of the Gerald Ford was done in pen and ink. So they would draw ink and vellum, and they would draw the drawings. The problem with the ink and vellum was the guy designing the piping system would pretty much design in a vacuum. He wouldn't know what everybody else was doing. And that's exactly what the 3D product model gives you, is you get all of the systems in the space at one time, and you start to see where the systems interact and where there are fouls.
Okay. So one big solution to increasing shipbuilding efficiency is this concept of modular design. Basically, you're building the ship in different sections. These different sections can be completed even by different companies or in different shipyards, and then they're attached together very easily compared to, you know, how it was done before, to form the final product. And this allows, this has many benefits. One of them is it allows for specialization. When you're just working on one section, you're a company devoted to one section, and you can really concentrate that. You can really specialize your workers and not have to have like the master workers. And if you're specializing in one area, you have a greater learning curve. You can also train people, you know, across different yards on this one section, and you can outsource. You can outsource companies that specialize in this kind of thing. All this really increases efficiency. In fact, one of the key companies that I found that's really embracing this method is Marinette Marine Corporation. they build those notorious littoral combat ships that are over budget, but they've really spent a lot of money trying to bring the assembly line method into their shipbuilding so that they can improve the process. This modular shipbuilding is a huge part of this. They basically have one building where they start all their fabrication, all their highly detailed components. Those move into another building where they're put together in modules, and then they move into another building where the modules are joined together. And basically the only thing limiting them right now is the crane size, which they plan to upgrade. They get bigger cranes, they can construct bigger modules and eventually move them out to the pier much more efficiently. The president estimates right now they're basically putting out 1.5 ships a year, but with all these improvements, they should be ramping up to about 6 ships a year. And like an assembly line, while one's going out one end, they're already working on one on the front end of the assembly line. And here's an overview of their new complex, all the different buildings they have. Another thing that they're big on is putting automation in the fabrication area. They can have robots do a lot of this welding that workers currently do. They don't even need to fire their workers. They just repurpose them for other things, and they estimate they can double their steel output. The automation can do a lot of the mundane tasks like basic wiring or construction of the frames. And when you put all this together and you consider the timing of your products, you have something that looks like this, more like an assembly line where you're working on one thing, it moves to the next area, then you're redoing that thing, and it just makes the whole process more efficient. Now, timing is a huge thing as well. This is basically the way the process works for building a ship. A delay in any one of these areas puts the whole project off. And basically you got workers sitting there doing nothing, or they get retasked to other things, translates to higher costs and delays. And so if you can really work on your timing, getting everything timed so that for example, they prefabricate a lot of their hot work so that you don't have to go back and do it later. Every time you have to go back and do hot work later, like welding, then you have to repaint and all that stuff. Well, they try to get it all out of the way at once in all the different areas, so when the time comes to paint the ship, they only have to do it once. So with timing and automation and modular shipbuilding, you can really start making this process more efficient. Now, another area that they've really been looking at is something that's near and dear to our hearts, lean manufacturing and Six Sigma. Lean manufacturing, focuses on cutting out all the things in the supply line that don't have any value and just add waste, to where Six Sigma seeks to reduce variation and improve the quality. And if you fuse the two together, you get this concept called Lean Sigma, which improves the quality, the delivery time, and basically the efficiency of your supply chain all at once. The end product being better, more reliable ships that have less variation in their components, and higher quality, all coming cheaper and quicker.
Engineer Tim Schweitzer is working to change the shipyard by using the same approach as Volkswagen, a philosophy called lean manufacturing.
It's a term that came out of the car industry, but to us, it's all about trying to identify and cut out as much waste as you can to lower your costs and improve the efficiency and the speed by which you do your work.
So basically, you're trying to get rid of all the fat in the whole process.
That's exactly right.
So what are the things that you're doing now that were different from before?
We used to do what we call stick-built carriers, and you build every piece into the dry dock and build the carrier from the bottom up. Now you see we do a lot more modular construction.
What Tim's doing is to use the lean philosophy to reinvent the way warships are made.
So to go ahead and wrap this up, there are many, many opportunities for industrial engineers and technologists in this industry to get on board, make things more efficient. Many of the concepts are already being used by the commercial shipbuilding industry, modular shipbuilding, contracting certain tasks out. I would say that the biggest overarching concept that people ought to keep in mind is the idea of putting your equipment in motion having it go past the workers, having the workers standing there doing repetitive tasks and not getting tired, and only needing to be trained at that one task, far more efficient than having an army of master shipbuilders. The other thing that's clear is the need for this. I mean, if any of you guys pay attention to the news, there's a lot of things going on in the world. Piracy, rogue regimes launching their ballistic missiles. You got people trying to take over parts of the ocean, like in the South China Sea, and you need ships to sail through there to tell them, hey, these are still international waters. And then you have Russia doing its thing, and the Middle East. There's going to be a need for ships, and they're going to want them to be cheaper and cheaper and more affordable. And that's what we do as industrial engineers. So if anything, maybe this presentation made some people aware of the opportunities that exist here. With that, I will take you on to my bibliography.